Today's lesson is R.7 Day 2, Radical Expressions. And as you can see, I've worked out the first couple problems as like a warm-up. One thing that I want you to kind of keep in mind, whenever you have a fraction in a square root, you can break up the square root into the square root of the top and the square root of the bottom. So that's what I've done for all of these, and then you can see they reduce really evenly. For this one, notice my negative sign here stays out front of the entire problem because the negative is not inside the radical. And then I split up the cube root on top and the cube root on bottom, and you know that 2 times 2 times 2 is 8, which is why that radical in the denominator simplified. And the top doesn't, so you just leave it as negative cube root of 3. And then the third example here, again, I split it up into fifth root over fifth root. And so then I have the fifth root of s on top, which there's nothing that you can do to that, but the fifth root of t to the 5. Those 5's cancel and the radical goes away and you're just left with t. So a little bit of review as far as radicals go. And then I want to talk a little bit about rationalizing the denominator. So this might be a term that you've heard in Algebra 2 before or in Algebra 1 before. What it means is that you can't leave a denominator in the bottom of a fraction like this. This is considered not simplified because of the radical in the bottom. And so something that you will probably have done in the past in Algebra 1, hopefully it sounds familiar, is that whatever that radical is, you have to multiply the top and the bottom by that radical in order to reduce it. And so when you multiply across the top, they're not like terms, so remember that you can't combine them because one's a 4 and one's a radical 3. So what I'm going to write in the numerator is just 4 radical 3. Pretend like that radical is an x almost. When you multiply 4 and x, it's 4x. So 4 times radical 3 is just 4 radical 3. And then the weird thing is that look at what happens in the bottom. In the bottom, radical 3 times radical 3 actually gives you radical 9, which you know is 3. So we have 4 radical 3 over 3 here. And look, what the whole purpose of that was is that now there is no more radical in the denominator. And that's what we wanted. We wanted to get rid of that radical. Okay, so that's considered completely simplified. Make sure that you don't reduce these 3's. One's radical 3 and one's 3, so those actually don't cancel. You would be able to reduce the 4 and the 3 if possible, but that fraction is already in lowest terms, so just beware about that. So hopefully that kind of rings a bell for rationalizing. What's weird is that now I have one with a cube root. And so this cube root here makes this a little bit different. So what that means is I need groups of 3. Groups of 3. Makes it a little bit different. And again, we have a radical in the denominator, so I cannot leave this as simplified. I have to actually rationalize it. And so whatever you multiply to the top, you have to do to the bottom, and the little radicals need to stay the same. So I'm multiplying the top and the bottom by a radical 3. And since that's a radical 3, I need groups of 3. So think about this as 1, 2, and I need 3 of them in order to simplify completely. So I'm going to write 2 squared here, because that will give me 1, 2, 3. You're looking for groups of 3, and that's what the huge difference that number in front of the radical makes. And so the other thing that I have in here is I have 1x. I need a group of 3. So how many more do I need so that I have a whole group of 3? I need 2 more. And whatever you multiply to the bottom, you have to multiply to the top. If you want to write 4 instead of 2 squared, that's fine, but since I'm kind of explaining the process here, I'm going to keep it as 2 squared. So now we're going to multiply straight across the top. I have x, and I have this weird radical. And I can't put the x inside the radical, so I'm going to leave it outside. And make sure you keep the 3 with the radical. What do I have on the inside there? I have 4 and x squared. That's the numerator. And now what's cool about the denominator is I'm just going to combine everything underneath one big radical. And the radical keeps that 3 in front of it the whole time. So think about this 2 and these 2's. So 2 times 2 times 2 is 8. And I have this x, and I have these 2 more, so that makes x to the 3rd. And now you can see that the radical simplifies in the denominator. All of this simplifies. So the numerator stays the same, but the denominator becomes the cube root of 8 is 2, and the cube root of x to the 3rd is just x. And the last thing you can do here is that I have an x in the top and an x in the bottom. Those are not inside the radical, so I can reduce them. So my final answer for this one is the cube root of 4x squared and 2 in the denominator. So some of you might be wondering, well, can't I square root both of this stuff? Well, yeah, you could if it was a square root, but it's not. It is a cube root. Okay, so that 3 means that you have to have groups of 3 in order to simplify it. So just keep that in mind as you're simplifying these things, okay? So let's try a couple more. Here's another one where we have a radical in the denominator, and so I'm going to need to multiply the top and the bottom by something, and the radical needs to stay the same, top and bottom, and I'm looking for groups of 5 here. I'm going to actually point that out. Groups of 5. And here's something that's weird, is that this 4, I'm going to change it into 2 squared. So just kind of think of that 4 as 2 squared because I need groups of 5. So right now, if the goal is to have a group of 5, I have 2 2's. That means that I need 3 more. So 2 to the 3rd. I need a group of 5. Again, there's 2 2's here, and I need 3 more in order to have a whole group of 5. So similarly with the x, this is 2 x's in here, x squared. So that means I need 3 more in order to have a whole group of 5. So x to the 3rd. And whatever you multiply to the top or to the bottom, you have to do to the top. So that part's the same. So now I'm going to multiply straight across the top. The 2 stays outside in the front. And my radical has to keep that 5 in it. And 2 to the 3rd is 8. I can simplify that now. And then x to the 3rd. And let's talk about what's in the denominator. I have the 5th root of multiplying everything on the inside of there. So I have 2 squared and 2 to the 3rd, which I'm just going to write as 2 to the 5th, which is 32. I'm just going to leave it as 2 to the 5th, or you could change it to 32. That part doesn't matter, because it's going to simplify anyway. Now we have x squared and x to the 3rd, which makes x to the 5th. This is my final answer. The top is going to stay the same. And the numerator, so look at the 5th root of 2 to the 5th and the 5th root of x to the 5th. And the whole reason that we did that is because the 2 simplifies and the x simplifies. And last thing you can do to reduce the fraction is cancel these 2's. Okay, so final answer there is just the 5th root of 8x to the 3rd over x. One thing to keep in mind is that, especially when you're doing your Math Excel, make sure that there's 2 different buttons. One of the buttons has a little box here with a square root, and one of them's just a square root. So if it's not a normal square root, you need to use this one in Math Excel. Just kind of keep that in mind, and you need that number with the radical the whole time. Okay, let's do this one. Nice. I notice at looking at this one that there is some simplifying that we can do right away. Look, the 3rd root of x to the 3rd, the 3rd root of y to the 4th, there's some y's that can be pulled out there, and the 3rd root of z to the 4th. So I'm going to reduce as much as I can. Reduce first. I'm going to split it up into a cube root over the cube root so that I can see it a little bit easier. The denominator is z to the 4th, and the numerator is x to the 3rd, y to the 4th. So this is kind of like what we talked about a few days ago, where what you can do is look for groups of 3. And so the numerator is going to simplify into there's one group of 3 with none left over, and there's one group of 3 y's with only 1 left over. So that's the simplified version of the top. The cube root and the x to the 3rd simplified, the cube root and the y to the 4th simplified. This is one group of 3 with 1 left over on the inside that didn't get circled. And then same thing for the denominator, z to the 4th. There is one group of 3 in z to the 4th, and there's one z left over on the inside. And so this is what we did a few days ago, was we just simplified the radicals. And now what you have to recognize is that we can't leave this radical in the denominator. We have to rationalize. And I need a group of 3, and there is one z in here. So what I need to multiply the top and the bottom by is 2 more z's, so that I have 3. Multiply, multiply. So in the numerator, what I'm going to have then is x and y on the outside, And on the inside of the cube root, I can combine, because they're the same radicals, I can combine the y and the z squared. They are the same radical, so you can shove them under the same radical. And in the denominator, I have this z, and I have another group of 3 radical z. So if I want to show like all my work, since I'm kind of explaining this here, I have the z that's in front, that's this one, and then I have the cube root of 3 different z's, which simplifies to another z. So I have this z times this one, so it ends up being z squared in the denominator. And the numerator stays the same. Xy cube root of yz squared. Okay? So kind of confusing. My advice would be to simplify first so that you can then rationalize just a tiny little bit. We only had this to rationalize as opposed to thinking about a lot of other stuff going on. Alright, so this next one, there's a little bit of simplifying we can do, the 16 and the y to the 4th, so why don't we go ahead and simplify that. I'm going to split it up into the 4th root of 16x squared y to the 4th, and the 4th root of w squared z to the 1st. The numerator can simplify a little bit, so if you just kind of think about the 4th root of 16, well, that simplifies to 2, because 2 times 2 times 2 times 2 is 16. So I can pull out a 2, and I can also pull out a y. See how there's 4 y's here, and I need a group of 4? And then the only thing I have left in there is the x squared. And the denominator, nothing simplified, so it stayed the same. So now what I need to do is get rid of this denominator in the bottom, or the radical in the bottom. You can't leave a radical in the denominator. So what I'm going to do is I need groups of 4, so I'm going to multiply the top and bottom by the 4th root of something. And so I have 2 w's, I need a group of 4. So I'm going to do 2 more, that makes me have 4. I have 1 z, I need a group of 4, so I need 3 more. And whatever you do to the bottom, you have to do to the top. So now let's multiply straight across. I have 2y on the outside. And on the inside of my radical, I have the x squared here, a w squared, and a z to the 3rd. So I got to write all that. X squared, w squared, z to the 3rd, over. In the denominator, what I'm going to have is the 4th root of, I have w squared and w squared, which makes w to the 4th. And I have z to the 1st and z to the 3rd, which means z to the 4th. That means that I have the same numerator, all of those exponents and variables, and the denominator simplifies just to w and z. Quick check to make sure nothing reduces here, and it doesn't, so we are finished with this problem. So here's the cool and fun part, is that for reducing indexes like these examples over here in red, these fractions all reduce, and so in order to see it, it's actually really quick, but I need to explain kind of where the thought process is on how to do these. To reduce indexes, the first thing you want to do is that translation. So turn that back into a fraction, meaning turn this into x to the 3 over 6. Remember, the top number goes in, the bottom number goes out. So remember how to do that translation. There, that 3 is here, this 6 is here, and that's how you translate all of them. And then our instructions tell us to, number 2, reduce the fraction, which is x to the 1/2. And then step 3 is actually really important. Translate it back, meaning into the radical form, that radical language. And what I'm going to be consistent with on my quizzes and tests is that if the problem starts in a radical, I do not want your answer to have a fraction exponent. I want it to have a radical in it. So now that you know the 2 different languages of radicals and fraction exponents, you need to be consistent throughout each problem. So all of these start with radicals, so my answers are going to end in radicals. But if I turn this into x to the 3 over 9, that reduces to x to the 1/3, which is equivalent to the cube root of x. So they're actually really, really simple. And yes, a shortcut is just to divide these numbers by the same. So divide both of those by 3, you get 1/2. Divide both of these by 3, you get 1/3. Divide both of these by 2, and you get, we'll see in just a second, change it into x to the 6 over 8, which reduces to x to the 3 over 4, which is the same thing as the top number goes inside, the bottom number goes out front. And so that's what that one simplifies to. So it's just reducing, and it's pretty quick and easy to do that. So whatever questions you have, bring them tomorrow. We will finish the rest of this page tomorrow in class. Have a good night.